Since a few decades ago, climate change has increased the number and hazard level of forest disaster events. These include severe loss or damages to forests, with both direct and indirect consequences to human livelihood. In general terms, forest disasters include forest fire, landslides, and pest outbreaks. A forest fire is an uncontrolled event that burns trees and plants in mountain regions. Forest fires have increased globally over recent years due to climate change. Similarly, heavy rain has frequently triggered landslides in mountain and urban areas, causing many casualties and substantial economic losses. Pest and disease outbreaks mean the population of any insect pest rising beyond the economic threshold. Pests and diseases differ from other types of disasters because they are relatively slow-moving, and their impact may play out over periods ranging from months to years. It also becomes a threat to the forest ecosystem and human beings as well. These three modules will provide an overall insight on forest-related disasters occurring in Asian countries, and introduce the current approaches to control forest disasters in the Republic of Korea. Module 1 introduces the causes and types of landslides, and risk management methods to mitigate the damages. Module 2 discusses the Geographic Information System (GIS) framework to manage landslide susceptibility and risk. Module 3 covers pest outbreak management in forest ecosystems. Although disasters may be completely or partially natural in origin, their impact will largely depend on local or national governments' preparedness and response. Landslides are serious geologic hazards common to steep, hilly, or mountainous terrain. It's the downslope movement of soil and rock under the direct influence of gravity. Landslides are caused by changes in slope stability, often triggered by undercutting from road and building construction, changes in water saturation, loss of forest cover, volcanic eruptions, or earthquakes. A single or combined causes can trigger landslides. Hill slopes in mountain regions worldwide have experienced rapid development, increased population growth, and associated demands for agricultural and residential areas. Various human activities can weaken the stability of slopes and could result in slope failure during high rainfall. Most landslides on steep slopes are mainly generated during an intense storm period that is likely linked to climate change. Rainfall-induced landslides occur when the soil layer is completely saturated. Even short-term but intense rainfall can also trigger landslides. The rapid infiltration during a storm causes a temporary rise in pore water pressure, consequently reducing soil strength. A close relationship between rainfall characteristics and the activation of landslides is observed in many landslide events over the world. There are many different ways to classify landslides, but the standard is to classify them primarily by movement, sometimes incorporating the type of material. Types of movement are divided into 5 main groups: falls, topples, slides, spreads, and flow. Materials are divided into 2 classes: rock and engineering soils. Soils consist of debris and earth. Both movement and material may vary from place to place, from time to time. Let's look at each movement type. A fall starts with the detachment of soil or rock from a steep slope along a surface, where little or no shear displacement occurs. Falls are abrupt and fast. A topple is the forward rotation and movement of a mass of earth and rock caused by gravity. This kind of slope failure generally occurs around an axis or point at or near the base of soil or rock slopes. Toppling may lead to a fall or slide of the displaced mass. Topple ranges from extremely slow to highly rapid, sometimes accelerating throughout the movement. A slide is the downslope movement of a soil or rock mass occurring on the surface of rupture or relatively thin zones of intense shear strain. The displaced mass may slide beyond the original rupture surface, covering the slope's original ground surface. There are rotational slides and translational slides. A spread describes sudden movements on water-bearing seams of sand or silt overlain by homogeneous clays or loaded by fills. Spread is the most common ground failure during an earthquake. Such movements may extend to many kilometers in exceptional cases. A flow is a spatially continuous movement in which shear surfaces are short-lived, close-spaced, and usually not maintained. The stability of a slope is expressed in terms of its safety factor. The safety factor is the ratio between the resisting strength, resisting force, and the acting force, driving force. The slope is stable when the safety factor is larger than 1. When the safety factor is smaller than 1, it indicates slope failure or the potential for failure or landslide. The basic principle for a stable slope is to reduce the acting force. This is the force causing land movement, or increase the resisting strength. To stabilize slopes, the following can be done. Reduce the slope angle, remove weight at the head and add weight at the toe of the slope. Add reinforcement and weight at the slope toe. Add a horizontal or vertical drainage to lower the water table. Add a wall reinforcement with anchors, or a combination of wall and drainage system. Landslides can carry quite a bit of sediment mixtures along a hill slope, and these can move dangerously quick. One effective way to prevent damages caused by debris flow are barriers. Debris flow barriers are classified as either closed type, check dam, or open type, flexible barrier. A closed-type dam is a small structure constructed across the mountain torrent or stream. It is the most effective measure in retaining sediment discharge in mountain regions. Landslides and debris flow are the major issues of sediment-related disasters in mountain streams of the Republic of Korea. Currently, open-type dams such as slit or buttress check dams are widely used. This type of barrier can still allow fish migration and aquatic animals movement. Different types of check dams are used to reduce landslides and debris flow damages since 1986. In 2022, more than 13,000 check dams have been implemented in the Republic of Korea. This structure is typically designed on small forest watersheds of less than 300 hectares, with heights of 5 to 7 meters and lengths around 30 to 50 meters. Trees and forests play important roles in reducing landslide risks. Trees increase slope stability. Tree roots reinforce soil layers, anchor the soil to bedrock, and retain surface materials against soil movement. Additionally, trees reduce landslide risk by reducing soil moisture through transpiration. Furthermore, trees help reduce soil erosion and can act as a natural barrier against rock or debris flows. However, sometimes trees and forests can increase landslide risk. First, by imposing a load on unstable slopes, and second, tree roots can pull on the soil under strong winds. To avoid such dangers, we need to ensure optimum rooting in the weak soil zones. Hydrologically, a layered vegetation structure may be suitable. Shallow-rooted species, trees, and shrubs will increase soil suction in the upper soil layers, while deeper rooting trees will reduce pore water structures at depth. Although woody vegetation may help prevent shallow landslides, forest cover has a lesser effect on deep-seated landslides. The removal of trees and shrubs from hill slopes makes slopes susceptible to landslides. Deforestation of steep slopes may temporarily reduce evapotranspiration and lessen root reinforcement, thus potentially enhancing landslide susceptibility. For example, Forest clear-cutting in regions with steep topography and high rainfall has been reported to increase landslide events by 2 to 10-fold. Loss of protective function persists until woody vegetation is re-established, and sufficient stem and root density are achieved. Forest harvesting increases the likelihood of landslide initiation during the major rainfall event. Generally, landslide frequency in logging areas is higher than undisturbed area. Where logging takes place, susceptibility is substantially reduced if selective silvicultural systems are employed instead of clear-cutting. Within 3 to 5 years, small roots may lose over half their original tensile strength, and significant increases in landslides can happen after this. The window of landslide susceptibility may remain open for 15 to 20 years, about 5 to 7 years in the humid tropics where regeneration is quicker, and longer at high altitudes in temperate regions where regeneration is slower. An important part of emergency preparation is the development of information about the location and timing of landslide initiation. In the Republic of Korea, landslide early warning system has been developed and operated by the Korea Forest Service. The multi-tank model is used to establish a warning threshold for landslide initiation. Tank model is a simple and conceptual model to predict the water storage for different soil layers. Soil water index and the calibrated tank models are employed in the National Landslide Warning System, with a goal of a pre-1 hour forecast for landslide likelihood in a national scale. When heavy rainfall is expected by the Korea Meteorological Administration, the Korea Forest Service calculates the soil water index using the tank model and compares it to the warning threshold for landslide occurrence. If the forecasted soil water index exceeds the threshold value, the landslide warning or alert messages are delivered to the people through the emergency broadcast system and SNS message on their cell phone. Korea Forest Service estimates the possibility of landslide occurrence for 5 different regions over the whole country. Most parts of the world experience landslides or more chronic mass wasting. Although statistics on damages from landslide events are highly variable, direct and indirect costs are recently increasing due to climate change. Therefore, a better understanding of the landslide triggering mechanism is necessary to control landslide-related disasters. In the Republic of Korea, both structural and non-structural measures have been used to mitigate and reduce the risks and impacts of landslides. With increasing concerns on the negative ecological impacts of closed-type structures, the Korean government is developing low-impact and eco-friendly technologies for managing landslide-related disasters.